So far, we've been talking about motion in a straight line. Now, Chapter 6, curved motion. First, we'll do projectile motion. We're going to start with a ball, and it'll be dropped straight down. Now, can you tell from the spacing that it's speeding up? Now, let's imagine that's me up here watching the ball fall down. But I'm on a bus going that way. What does a kid on the sidewalk see looking at the bus going by? Everything is moving this way. I move that way. The ball is moving this way. And in the time it takes for the ball to get to this distance sideways, it's fallen to this position. In the next time interval, I move over the same distance. The bus is moving at a constant velocity, but the ball drops further down. And again, I move over another time interval, the same sideways distance, but the ball dropped further. Now the bus has made it all the way over to here, and that's where the ball lands. I see the ball just dropping straight down. This kid sees the ball following this trajectory. Now imagine which ball lands first. Well, they both got to land at the same time because it's only one ball. Let's see how this works with a little math. Let's say the bus is moving at 10 meters a second. And here are the times for each interval, 0.1, 0.2, 0.3, 0.4 seconds. The bus moves 1 meter in the first interval. How far would the ball fall? Just use distance equals 1/2 gt squared. We're using 0.1 seconds. That's 4.9 centimeters of drop. Now we go another meter. And the ball has fallen for 0.2 seconds. That's 19.6 centimeters. You get the idea. Now calculate how far it fell. 44.1 centimeters. And lastly, we get 78.4 centimeters. We call this distance the range. And that distance can be found from the velocity times the time. This velocity is the velocity in the horizontal direction. As you can see, we maintained a constant horizontal velocity. The force acting on the particle is down. You can see that by the spacing. So it speeds up vertically, but it doesn't speed up horizontally. Now you can see that the velocity horizontal was 10 meters per second times 0.4 seconds gives us a range of 4 meters. And you can see that because in each interval we went 1 meter. So what would happen if the velocity was 20 meters per second? What if the bus was going twice as fast? Would that affect how long it would take to fall this distance? It's the same vertical acceleration. So it's going to take the same time to fall that distance. But what will be different will be the range. The horizontal velocity is going to carry it way further in the same time it takes to drop. So 20 meters per second times 0.4 gives me 8 meters. So keep in mind with the projectile motion, the horizontal motion does not affect the vertical motion. So here's a problem. We have a ball that rolls along a table. The table is 5 meters above the ground. It rolls a distance of 1.5 meters in half a second. What's the range? Pause this video and try it first. Well, you know that distance is velocity times time. That's a horizontal velocity, and it will be constant. That's the horizontal velocity, and it will remain constant. That's the time it's in the air for. So we need that horizontal velocity. That'll be found by rolling along the table. That's 3 meters per second. Now, how long is it in the air for? That's not that time. That's the time along the table. How long will it take for that ball to drop to the floor? That's the question. Gravity pulling it down is what's going to make it fall. So we don't have to worry about a horizontal velocity. There is no VIT in this formula. The velocity is sideways. There's no vertical velocity. And we now have a time of 1.01 seconds. We're ready to do the math. Our range is 3.03 meters. Notice there's no new formulas here in projectile motion. I've got these projectile motion launchers at school. We're going to set one up on a table and launch it horizontally from a height of 1.1 meter. We're going to measure the range. We see it lands 4.5 meters away. Could you solve for the velocity of that projectile launcher? Now, you know the range is equal to the horizontal velocity times the time, and that's the time for it to fall to the floor. Well, we now know the height of the table, so we could get that time. Plug in 1.1 meters, solve for t. We have 0.474 seconds, and we know the range, so we can solve for the velocity. And that's the velocity. Now, how fast do you think that ball is traveling sideways when it's here? 9.49 meters per second. What's the horizontal velocity at this point? 9.49 meters per second. It's 9.49 meters per second all the time sideways. It's the vertical velocity that increases. So what is that vertical velocity on impact? Notice I put a y here. That's down. I get 4.65 meters per second. How'd I get that? All your kinematics formulas still work. But if that's in the y direction, everything over here has to be in the y direction. That means the initial velocity is a 0. How come? It's in the y direction. The horizontal velocity has a value. The initial value in the y direction is 0. So now we can solve for the final velocity. We know the time for it to fall. That's 0.474 seconds. And we know that acceleration is vertical. Y, 9.8. Now we can get the overall impact velocity. Pythagorean theorem, 10.57 meters per second. A little trigonometry, and we have 26.1 degrees below the horizontal. Now, what do you think the trajectory would look like if we launched a ball from the ground at a velocity of 20 meters per second at an angle of 25 degrees? You've seen this a million times on the ball field. Our job is to find the range. It's still going to be equal to horizontal velocity times time. Because while the ball is going up into the air and coming back down, the only force acting on it is gravity. Horizontally, it will remain at the same constant velocity. So we have to get the components. And we get 18.13 meters per second horizontally and 8.45 meters per second vertically. So we need to find the time for the entire flight. Now, can you picture that the y velocity is going to carry it up and gravity is going to bring it back down? So we want to find the time to the top and then the time to come down. In the y direction, we can say that the vertical acceleration is y final minus y initial divided by time. When we get to the top, we have no vertical velocity. Yeah, we have a horizontal velocity, but I'm doing a y problem right now. Putting in a 0, bringing the acceleration here and putting the time here. Now remember, this is down, that's up, and they're in two different directions. So this is going to be a negative 9.8. The negative sign is from the formula itself. It cancels, and now this is time up. So we get 0.862 seconds to reach the top of the trajectory. How long is it going to take to come back down? Same amount of time.